Hi, this is Jeroen, and this is Anchorman's AI journey. Tune in to get inspired by the opportunities, impact, and capabilities of data, machine learning, and artificial intelligence. Together with my colleague Ron, we will be talking about developments, best practices, and lessons learned from the field. So get ready. So everyone listening, welcome to the to Anchorman's podcast on how to make your company or your organization smarter with AI. I'm joined here by my partner in podcast, Ron Dodge. Ron, could you please introduce yourself?
Hi, Jeroen. Well, thank you. I work at Anchorman as a senior data scientist, and I'm working on various projects, most of them related to either AI or data science. And I'm also have a background in psychology. I have a PhD on social psychology and on stereotypes and discrimination. So I like the interface of humans and AI.
How long have you been with us?
Over a year right now.
Over a year.
Yeah.
Feels much longer.
Yeah?
That's a good thing.
Yeah. Very good. Yeah. Part of the
core, yes. Indeed,
yeah.
Indeed.
Nice, thanks.
So
maybe you want to introduce yourself as well.
I would love to. So my name is Jeroen Fleck. I'm the CTO of Anchorman, thereby responsible for all the engineering and data sciencing that we do. And I've been with Anchorman almost for 5 years. Before that, I worked in other consultancies and online gaming as well, which
Any games we know?
No, but it was in Germany. It was huge. C-Fight, it was called.
C-Fight.
Lots. We can cover that if we ever do a podcast on technical debt.
Okay.
That's where I really learned about managing technical debt in a good way. So that was great. So I just finished a book by Ben Horowitz, which is this venture capitalist in Silicon Valley, who wrote this book called "What You Do Is Who You Are." And he said that actually in his company, they also try to embrace this diversity, because he said people are different, and depending on the job that we're looking for. So, well, first of all, they make like this profile that they're looking for, and then they make sure that different ethnicities are on the hiring committee, because they look at people also differently, but also they help craft the things that are important for the application text. So thereby kind of trying to reduce what you just said, like that people can hide behind, like, okay, I can see like this person is of this color and this person of this color. They're equally good, but I want to pick this person because of my personal bias. But then people can't hide behind that, because actually the job text has been written for a certain position.
Yeah,
Do you think that will help? Or
that's interesting. Yeah, I think there are a lot of things there that are related to humans that might be, let's say, out of scope for this discussion now. But what I think is interesting
nothing's out of scope.
No, there's nothing out of scope. What I think is that what's very interesting is the fact that you embrace. If you say you embrace diversity, what it actually means is that you accept the fact that people are different, right? And that they don't, and that you can make a difference between peoples, and that each have their own unique qualities. I think in the end, that then means that it's okay for also an algorithm to make a decision, accepting that somebody becomes, accepting that somebody is different from somebody else, and therefore somebody might be more suited to the job than other people. And the problem is there when turns out to be some kind of systematic way of underrepresenting, even when people are equally well suited for the job. If you make an algorithm, or you have a human who then always chooses for one group instead of the other group,
right?
And so maybe like the diversity,
but an algorithm would never be, well, maybe indirectly, like more as a latent factor. Well, like for example, the someone's sexuality or their race. That's usually something you don't put into an algorithm, right? But I think what Ben Horowitz was also getting at, it's not so. If you think of looking for someone as a question, right? Formulating a question, it's not only about the answers that are provided, but it's also about how you formulate the question.
Okay, so yeah, that, and I want to add also what explanation you give for how you get from the question to the answer, which is also very important in terms of transparency of algorithms and not going with black box algorithms, and there are some solutions that we can discuss later about that. Going for actually training algorithms in such a way that they also give an explanation of how they come to their
How
conclusion.
far are we with that actually? We as being
Okay. So
the world at large.
So actually, there are some cool techniques right now where you can, So let's take a couple steps back. First of all, so how can it be the case that an algorithm ends up being biased if you don't put things like race and gender in your input data, right? So an algorithm is not trained on something that might be indicative of the group membership as an actual explicit variable. How can it then still be biased? And there are a couple of reasons that can happen. So first of all, there may be other variables in your data set that the algorithm trains on that are not directly race or gender, but they might be related to it. So for instance, if it turns out that, let's say we live in a world where women don't have the same opportunities as men, which actually we do.
Yeah.
And so then there is a slight shift in, for instance, men are more likely to go to, better universities, maybe have more technical backgrounds in their education. Then what will happen is, even if you don't code for whether somebody is female or male in your data set, but you still take into account what kind of education, what kind of university they went through.
Which makes sense for a hiring process.
Which makes sense for hiring process. Because these are correlated with gender or socioeconomic status or race, this effect still trickles in the end results, and people might still be more likely to be picked if they're male or and coming from white upper class universities as opposed to other from people from other groups. So that's how that can work. And then how can you deal with this? There are a couple ways to deal with it. So first of all,
so just 1 second. As I said, that maybe you shouldn't then put that into the hiring process. Well, it's
you mean the algorithm or what?
No, the university they went to.
Well, yeah.
Right. So ideally, you have this completely agnostic test.
Yeah.
Which you put, but then the problem is, of course, that there are probably so many applicants. You need to do a pre-selection, and the pre-selection is usually done based on these kind of factors.
Well, yeah, and I think the other problem there is the algorithm, the machine learning algorithm, just learns to find the variables that are the most predictive of, and then the question is of what? So job success or hiring decisions in the past from humans. If what you train the algorithm on is based on what people were hired previously, then those biases will get in there as well. But let's just park that for a second. Now, let's say you are aware of the fact that what university somebody went to is biasing your results. There are two questions. First, how do you know? Well, now you know because we were talking about it and you were thinking deeply about it. But there might always be variables like that which you are not aware of, especially if you're white, male, person, data scientist working on this,
unaware. Yeah.
Completely oblivious to whatever is as people who do not have privilege. Let's call it that way. So we don't know. So first of all, that is where diversity would happen if it's not just white male data scientists who work on the algorithm. But that's one thing. The second thing is that how can you actually enforce that an algorithm is fair? That becomes there are solutions to that. First is, for instance, making sure that your training set is unbiased. That's very hard, as I said, because some of the variables you don't know that might be biasing because they're correlated with other things that might be biasing. But then there's also ways to train your algorithm in such a way that it enforces fairness. Now, for the more technically inclined people who are reading, this could be, for instance, putting fairness as a component of your loss function. Training your model such that a set of people are not less likely to be hired than other sets of people.
How would you? So we shouldn't be too technical, but how would you model that? You would, for example, then look at the resulting spread.
Yeah, for instance, or you would just compute for a hypothetical person how likely that person would be to be hired, and change one variable, namely whether that's a black person or not. You can take it from the data set or whatever. You can augment the data set with this kind of thing, and then you would kind of look at how much more likely is one person to be higher than the other person.
Right.
I mean, this is very simplistic, but that could then, and then if it turns out that there is inequality there, the training algorithm is punishing that result and will make it less likely to get to a model. That's that. And then
just to also, because what's interesting what you said about luck and being fair. It kind of reminds me of this story I once heard where the hiring manager had like for a certain position 200 resumes on his desk, and they were like a smaller company. It was way too many to process them all, and he just took the top 100 and threw them in the paper trash and said, "If you don't have luck, you don't get to work here."
Yeah. Well, that assumes that luck is...
It's not unfair.
No, it's totally not unfair. It just is also probably not good for business because it assumes that luck is a stable trait that will help you the rest of your life. Yeah, I'm pretty sure it was a stupid decision. But okay. So I mean, and then so another thing that you can do to solve this whole problem is one way is and this also leans towards explainability and transparency of these more black box algorithms. So first of all, we have algorithms that are very powerful but black box. We don't know what happens on the inside of such a trained model. So if somebody does not get hired and then wants to know why, we cannot say.
Yeah.
Right. So that was up to the past couple of years. That was the state of the art, and right now we're moving beyond that, and we can talk about what we're doing there. The idea is if you can explain why you come to a specific decision, it becomes more ethical, right? Because you can make people understand.
Well, you can make the process more ethical. Just explaining the decision itself is not necessarily ethical. Like an unethical decision, explaining that doesn't make it more ethical.
No, that's right.
But it can help you. It can help you become more ethical.
That's right. Well, I mean, one thing is that I think that you're taking out of the loop is more like the computer says no response. Like the people who do not understand the algorithm are using the algorithm to make hiring decisions, and then when somebody asks you why the hell do I not get the job? I'm qualified. This job. I'm completely suited to this job, and then you say, well, the computer says you can't have the job. But the cool thing is that what we can do right now is if you have a data set where you not only have, a training data set where you not only have the person's information and then whether that person should be hired according to some criteria. It could be either that person was hired, which I don't recommend because then human biases come in, but maybe job success after 5 years,
right? Or
retention, right? Whether that person is still working with you for 5 years.
Yeah.
But not only that, but also have some kind of explanation.
There's a risk there as well, right? So this just to say that everything in life is a trade-off, especially in AI and software development, right? Where you're optimizing along several variables all the time. Is that maybe the people that started with you 5 years ago are not the right fit anymore? Right,
oh,
so that's not necessarily something you want, right?
So yeah, that's totally true. I mean, the whole process of exactly figuring out what you are going to use as a proxy, what you want to base your hiring decisions on, that should be the variable you're using to train your network on, right? So or your algorithm on. So if I say I want people who bring in a lot of money to my company because they're good salespeople or something, then you could either look at the salespeople that we have, look at what traits they have, and look at how much money they bring in yearly, and then train a network on that. But times change. Maybe 5 years from now, a good salesperson somebody who was a good salesperson now is not a good salesperson 5 years from now because suddenly sales happens through virtual reality, social media, and these people don't understand that. That's possible. So maybe you want to focus on more stable or more general traits, and then maybe you might use different kind of criteria for judging whether somebody's a good salesman or not.
I think it then like extending that line, you could even of course say that it first starts with your company's culture.
Oh,
if you have a broken culture at your company, then your AI is not necessarily going to help you because that's a bias by itself, right?
I totally agree, but that's like even more bigger picture, right? So
we zoom out or we zoom in?
I mean, that's a great discussion because the question then becomes: don't use AI to fix your broken company. First, fix your company, and then see how you can use AI. But let's go back to the explanation part because I think that's an interesting
explainability
part.
In AI. Yeah. Shout out to Gary Marcus.
Well, yeah, I think there you go, Gary. So if you have data where you have, let's make it more abstract, where you have information about a person, you have a decision about a person, and you also have data about why that decision was made. And it can be like a categorical variable, like say 10 different reasons, right? It's more than no reasons at all. Normally you would only take information about a person and the decision being made and then try to learn the function that maps the information onto the decision, right? That's what the algorithm is doing, and regardless of what kind of algorithm. And then we have these black box algorithms that are like neural networks, deep learning, that are really good at finding that function. It's just impossible for us to figure out what that function is. Now, and because of that, there is a new way of training your neural network, and that's you don't only predict during at training time somebody's the decision is made, but also the explanation that's given for the decision. And then
I love how you though went from explainability in AI immediately to neural networks.
Yeah, I love it.
Again, shout out to Gary Marcus.
Gary should be on the show sometimes.
Yeah, well, that'd be awesome.
Let's invite him.
You're invited. Yeah.
I hope he's listening.
Yeah, I hope so too. But because I've seen a while ago, I've seen these efforts, which at least for visual data, it's easier because you can just visualize kind of like the blobs and patterns. That kind of the ways get tuned to.
Even there. So let's say
still difficult.
You're doing computer vision, right? Let's say you're doing convolutional neural network, and you're trying to figure out why is this object detected as object A? Why is that object detected as a cup of coffee? I mean, one way to do that is you just have your convolutional neural network. You look at layers in between to figure out, okay, so what are the features that are lighting up, and you can visualize those. But you don't have
maybe just a brief explanation for you. A neural network tunes its internal parameters called weights to the target function it's supposed to approximate. And what you're talking about is that given a certain input, for example, the picture of a cat, that you can then visualize the different layers in the neural network to show then that if the network does say, oh yeah, this is indeed a cat, how it reached that decision because, for example, it detected whiskers and pointy ears.
Yeah, exactly. So here the question is, though, you don't have a guarantee that in that neural network that you train, that somewhere in this visualization of the whiskers is present. Even though it is predictive, it might be distributed across many neurons. Mm-hmm. And so if you visualize the effect of one single neuron...
And that's the challenge.
That's the challenge. Now, what you can do is you can force the network to represent the hidden layers, so the features it's using, in terms of things that are recognizable. For instance, by forcing those middle layers that are doing this visualization of these features to be as close as possible to actual features in the original image. So if you add this to the function that's the loss function that's kind of guiding the training, then what will happen is you will force the network to also represent its decision-making process in things that we are more likely to understand. So that's with computer vision. So basically, there are ways to technically make sure you better understand what the network is doing. Mm. Same thing goes for decisions. Let's say go back to hiring decisions, although I'm not sure whether it's been tried on hiring decisions. But let's say you have 10 different reasons why somebody is not being hired. So instead of coding for you're hired or you're not hired, you're forcing the network to also learn not just to say you should hire this person or you should not hire this person, but also why it should not hire or should hire that person. So there's no reason why a network is not capable of mapping that as well onto the information. And it turns out that actually when you do that, networks do not become worse necessarily in predicting.
So basically what you're saying is instead of saying, yes, you're hired, no, you're not hired, you make many more outputs where you say, yes, you're hired because, yes, you're hired because, no, you're hired, you're not hired because, no, you're not hired because.
Yeah. And so that's within our technical realm of possibilities now.
Yeah.
You just need to have a data set that is high quality enough and that has this. But if you have that...
Which is non-biased.
That's when we go back to our first point where your dataset should be non-biased at all times to just start off with that. So, but just to say that there's a lot of progress being made in trying to make AI more fair and more interpretable, more explainable, more transparent. And that even with these...
Well, I see a lot of initiatives pop up.
Yeah.
But are there already results coming out?
Yeah, so the things that I just mentioned, there are papers on that out there. But it's all academic. At the moment,
that's where it usually starts.
Yeah, that's where it usually starts. But the problem is really like it's a big concrete problem, and I think that by now society has started to understand how dangerous these algorithms can be because of the fact that they are so impactful on people's daily lives by now in all kinds of, whether you get an insurance or not, whether you get a loan or not, whether you get hired or not, whether you get hit by a autonomous vehicle or not, because there is a problem there as well. It's been shown that for some autonomous vehicles, they're more likely to hit black people than white people. And that's because they're less likely. They've been trained by a data set which included fewer black people, and therefore they were less likely to recognize a black person as a person.
Another anecdote. I think 2 years ago at the Big Data Expo, we had this. We used this classifier that recognizes a face, draws the bounding box, and then we got this. We used this classifier that tries to say whether tries to guess your age, your gender, and your emotion, right? Mm-hmm. And you could tell that there were two separate black women. They came by, and the algorithm really underperformed on them. But you could really tell that it was only trained on white people.
Yeah, and that's a big problem. And it's
so what I've heard is one of the reasons for that is, especially with these like facial classification, is that most of these algorithms are developed in the US and so at universities. And what do these students do to get, or these researchers do to get trainings data? They get students, which are also predominantly white, and mostly male at that, because it's computer science department.
The problem is even bigger than you think. So this is where I really get into my comfort zone, because I have been working on face perception a long time of my life. And so one thing that already, where the bias already starts, is the fact that we think we can build an algorithm that recognizes facial expressions. Actually, we make an assumption that like naive humans also make, and that's the fact that we can even read emotions from faces, which is like psychology. A lot, like years and years of studies of psychology actually show that the face is not the window into the soul, and it does not tell us exactly what emotion we're feeling. So, for instance, I can smile to you, but be very angry at you at the same time, right? Usually, we smiled a couple of times during this conversation. How many actual emotions have we actually found right now? We've made a lot of facial. I know that people don't see this right now, but we are making a lot of facial movements while we're talking.
It's mostly the coffee.
Mostly the coffee. But there are really not that many emotions that we're actually feeling right now. So it turns out that when people feel real emotions, or real strong emotions, their face, all their muscles get contracted. So their face looks like a really weird face. Actually, there is nice work from Hillel Aviezer and other people from an Israeli university that shows that if you give people, this was published in Science a couple of years ago, if you show people images of a tennis player, and you show only the face, and then you have to judge, does this person now score a point, right, win a game or not? They cannot do it above chance. Yeah. They cannot do it above chance. Yeah. The information turns out to be in the body.
Yeah, but this is at the same. I could also argue this is a pretty extreme situation, especially for like a tennis player where there's a lot on the line. But isn't it more in the day-to-day interaction with your colleagues that it's easier to assess, also because people, the sender also wants you to assess.
So because you want to communicate it that way. But of course, here's the thing. So it turns out that the face is less important than the context, for instance. So say, for instance, there's this other study by Hillel as well. Shout out to Hillel now. Hey, buddy. I actually know him, so it's okay. So when you look at a face that looks angry, and you make the body, like by using Photoshop, hold a dirty underwear, people will say almost with physicists that the person looks disgusted, not angry. Yeah. Right. So context matters a lot here. Right. And it turns out there are some emotions that are more confusable than with others, and that's just one point. Then the next point is that it turns out that there are many emotional dialects. So we are all not aware of that, but actually, if you grow up in the Netherlands, or let's say the West, versus if you grow up in, say, Japan, the expressions you make to try to communicate different emotions, they differ.
Of
They're
course.
just not the same. And the algorithm will have really a hard time to classify all the different dialects that are there.
Because it also comes back to being a high context culture or a low context culture. The Dutch being notoriously low context, right?
Yeah.
We make everything explicit. Sometimes a bit too explicit, according to my wife, who's non-Dutch.
All right.
But for example, the Japanese, everything is very high context, depending on is there someone elderly with you? Are there parents with you?
So how are you ever going to train an algorithm based on your student sample in the US university that is able to recognize all the expressions, all the emotional expressions? Is going, if this is going to be put into a robot, that robot is going to feel autistic to Japanese people, right? And that's not what you want to do. So, and this is where it becomes very interesting. There are many biases are there, not just in the algorithm or in the training set that's being used, but actually in the mind of the researchers who are developing all this stuff, right? So if you're not even aware of all this stuff,
I think it's interesting here that where, for example, right, the holy grail for AI is building artificial general intelligence, AGI, and then you ask what's AGI? Well, like humans, but we're not generalists.
No,
not by a stretch. Especially not even on a planetary scale. Let alone on a universal scale.
Well, yeah, and if you ever see me riding a bike, you also know that I'm not a generalist. No, I mean, true, definitely true. And that it's. I mean, I remember the first lecture that I had in AI back in the 90s. Where we saw this table where you have 4 cells of what does it mean to try to make AI? Is it appear to make decisions like a human, or is it actually make decisions like a human, or is it not even related to humans? Is it appear to make smart decisions or actually make smart decisions? And where actually make smart decisions means actually that it works in a way that we think it's smart, versus appearing to look smart. It's just if the results of the decisions look like there's an intelligent process behind it, that's good enough. And there's a difference between whether it's human-like or not.
Right, because also if it's really, really smart, then it should make decisions that we maybe not would have made as humans, but that are in the end good decisions.
There you go. With AlphaGo or AlphaZero, right?
Exactly.
Were you thinking about that as well?
No, I was actually thinking about Nick Bostrom, where he says, the smartest human is maybe an IQ of 250 points, right? And the dumbest human is maybe 30 points, whereby IQ, is also debatable whether it's a good measure of intelligence. But let's take it as a proxy. Then and let's assume we have an algorithm, an AI trained that has an IQ of 1,000 or 10,000. We can't even wrap its head around it. Our heads around it anymore.
Yeah, I understand what you're trying to say, even though that the IQ indeed is just a score on a test, so it's impossible to get that high.
Yeah,
and and it represents the standard deviation. Never mind that. I do agree with your sentiment a lot, and I think that. So why I mentioned AlphaGo and AlphaZero, right? So you have Google DeepMind was training using reinforcement learning a network that was able to learn how to play Go, right? At first by looking at a lot of games of Go.
That was the first version.
That was the first version.
It had also this lookup database.
Yeah, exactly. Yeah. And then next, they made an even better version that just learned to play the game by only knowing the rules and then playing games against himself, itself, herself, itself. Yeah, I don't know. Maybe we need to have a new gender for neural networks.
There's no gender.
No gender. Genderless. And then it turns out that network becomes so great at playing games that even the biggest champion is amazed and calls it the god of Go, because it does moves that nobody understands. There is this Netflix documentary about it, and basically you see that that all the reporters who are following closely the game, they are completely flabbergasted that the machine of Google is making such a move. Nobody understands why. They think it's a disastrous move. It's going to lose for sure. And then at the end of the game, it turns out to be a masterous move. Nobody expected that could be done in Go. It changed the whole world of Go, because now suddenly you can do it completely in a different way.
Now everyone's doing it.
Now everyone, yeah. So it turns out that these algorithms can point towards places that we, with our biases, do not think about at all. And that's the interesting part. So it can also open up, right? It can open up new ways of doing things. It can also show us that we had blind spots where we didn't know we had them.
Who do you think, like in a typical organization, where does this responsibility lie? right? You can't all burden this on the data scientist because.
Yeah, well, I agree. I don't agree with you because I think that the data scientists are. So my experience in working for clients is that usually the clients are relying on the data scientists to flag these kind of issues if there are problems. Also because sometimes they don't even think about it, right? And the data scientists, the well-trained data scientists, should know that these are important things and should know that your training sets should be unbiased, balanced, and should know that there are things that can correlate with gender, even though you don't put it in there.
But we also all know that sometimes under certain economic pressures, there are things we incur sometimes, technical debt, maybe even something like bias debt. And then at least get ship a product and then improve it the next iteration.
Well, I think that as a data scientist, you should still flag it.
Absolutely.
There's no reason to keep it under the hood. Yeah. And then at some point, if you get pressured into doing that, I think then you should flag it as widely as possible, and then it becomes somebody else's responsibility at some point.
But that's also where culture again comes in, right?
Yeah.
Your business culture and what do you think is important, and do you, for example, do you prefer short-term gain over long-term ethical behavior?
So what do you think then? Where lies this responsibility?
I think it should be part of the culture, and but I also think, for example, that the other stakeholders should also be involved with it and should also be, well, first of all, agree upon what the parameter space is, if you will, for such behavior, but also. And then of course, like in the end, like the very upper management, like saying like they need to make sure that there is a culture that also actually rewards ethical behavior.
Yeah. So I would say that you should institutionalize it, right? Whether it's ingrained in culture, it's implicit in there, but maybe you should also have an explicit, like say,
but so the thing,
ethic officer.
Yeah, maybe. Well, no. Maybe not necessarily. Like you mean like a chief data officer? Or
make it part of the protocol that whenever you ship something, it goes through like a review of these kind of things.
Yeah.
Like, I think it's important, especially when it's about when you know that you're working among a set of people who might not be sensitive to this issue.
Yeah.
Right. I do have to say that in the cases that I've been involved in, actually almost always this was not the algorithms that we made for the clients that I worked for were never about humans, and they were never about decisions about humans. They were about predicting growth in specific markets, or optimizing production processes, or using computer vision techniques to interpret meters. So it's never the case that it ended up being a decision there. But I do think there are some projects that we do that might have.
Yeah, well, I mean, at Anchorman we do have this. I think this culture that where I would be very confident to say that our data scientists would definitely flag this and would also raise the alarms if something unethical would happen. But bringing it broader, maybe not every culture is like that, right? Or there might be even like bugs in the culture, as Ben Horowitz calls it, where you think you have an ethical code of conduct.
But what you also sometimes see, and that's where the danger comes, is if you just start working with the data you have, even though there might be biases there and everything, and then you come up with something and you show it to be very accurate, then we get into big trouble, because then a lot of business users say this is good enough. But you need to have somebody who understands how to interpret that accuracy,
right,
in order to understand that it's actually not accurate.
Yeah.
So the example of unbalanced data, for instance, let's say, we had this case where we tried to do some predictive maintenance, right? We tried to predict whether something is going to fail or not, and we had many more examples to train our data on that something is going to that something is working okay, and we had only a few cases where something failed. So we're trying to predict based on some other information whether something is going to predict and fail. I don't need a computer to do that. I can do that in my mind. If 99% of my data set is non-failure cases. I can just always predict non-failure and get 99% accuracy. Right? So this is the problem of
which is why
unbalanced data.
accuracy is a poor metric, right? It's why you use something like precision or recall.
Maybe you want to explain precision or recall? You have asked me on my interviews.
Right.
How about you do it now?
So, well, if accuracy is just the ratio of correct predictions over all predictions, right? But then, if you do if you then predict always it's not going to fail, you might have 99.9% accuracy, but you really haven't learned anything. So for that, you might want to favor, for example, recall, where you try to, where it's more the ratio of things you selected over everything you could have selected, right? So, for example, if you go, I don't know if we should go into the confusion matrix.
I think maybe we should.
Well, you have.
It would be very good for business people.
So being positive, because precision and recall are actually two knobs you can really turn to optimize, and then you have, of course, your true positives. So where you predicted it is positive, positive and negative, just being labels could be A or B, but let's go for positives or negatives in a two-class situation, where you have the true positives, you have the true negatives, you have the false positives and the false negatives. So the false ones are obviously the mistakes, and the true ones are the correct predictions. And then recall is where you have the ratio of true positives over the true positives plus the false negatives.
Yeah,
so those are the things you should have actually classified as positives, right?
Yeah.
Like how many of the things you should have classified as positives you did classify as positives,
exactly.
Right?
Yeah.
And you have then, next to that, you have precision, which is the ratio of the true positives over the true positives and the false positives. Yeah. So that's for whatever you classified as positives, how much of that was correct.
So of those classified as, for instance, in the failure.
Did I get the job?
I think you got the job. I would hire you definitely. So if you go back once more, so precision and recall. So recall is of all the instances you should have classified as failure, for instance. You also have actually classified them as failure. So if you have 100%, it's basically you got all the failures right.
Yeah.
You got all those failures. You were able to predict all the ones that actually failed as failure. And then precision is of those that you have classified as failure, how many of them were actually also real failures.
Right.
So if you have a precision of 100%, you have all the ones that you called failure were actually failures. Now it's possible to have a precision of 100% and have very low recall, which just means that, let's say, of this 100 examples that I need, cases that I need to classify, and say 50 of them were failure and 50 of them were not. If I just pick out one of them correctly and say this was a failure, I have 100% precision, but I have almost 0% recall because I missed so many failures.
And these are the two knobs you can turn, right? Because you can, as a business, can kind of specify what's more important to you. Is it like if you call someone, for example, that wasn't supposed to be called, the costs of that are not so high, probably, right? For a person, you might have an annoyed person like, hey, why did you call me? But apart from that, it's okay.
You don't care too much about precision.
You don't care too much about precision. But for example, if you classify someone should get an operation, for example, in a hospital, then the cost of not classifying correctly are much higher, right? So, but then how can we? Would this open up a window also into more or like reducing bias? Is that something?
Well, I do think so.
Use?
So the story, like the narrative that we're following, and why we got to talk about precision and recall, is because we were saying, well, what if a company just says, let's start with the data we have, and that data turns out to be biased or unbalanced in this case. So unbalanced means we have a lot more examples of one class than from another class. And so what I also hear a lot from clients is just, precision recall is too complex for us to understand. Just give us accuracy, right? And so accuracy does not give you the story. You will not be able to see the bias in
which
if you
I
only
also
look at
don't
accuracy.
necessarily agree with. I mean, it's easy for us to say precision and recall is not that complicated, but actually, I strongly believe that precision and recall is actually what companies want. That's actually what they want to think about. They don't want to think about accuracy. They want to think about precision and recall.
Yeah, but they need to understand it first.
Of course,
and that's the thing.
And that's why it's our job to also frame it in their business context.
Yeah, I agree. And it is also related to ethics, right?
Absolutely.
Because as you said right now about the operation, you can compute precision and recall for different groups of people, right? So let's say we have an algorithm that says whether somebody should get an operation or not. And we have black people and we have white people in our training set, and it turns out for black people we have very low recall, whereas for white people we have very high recall. It means we catch all the cases for white people, we don't catch all the cases for black people. That's unethical. That's bias.
Yes. And it's easy to check.
It showcases also how you can go about in checking this kind of stuff. Even though the total accuracy might be fine, even the accuracy actually for both might be you might even have accuracy levels that are similar for black and white people. But the difference will be one have high precision, one have high recall. It means you miss a lot of black people, and you just err on the benefit of doubt, or on the side of the caution. You err on the side of caution for white people. Even though you find the same accuracy for both, and this is why precision and recall matters.
Absolutely.
Yeah.
And I think you could also even then make a case for open data, in the sense, obviously, or at least also involve open data, because I think open data, I'm going to go on a limb here and guess that is less biased. At least, it's easier to maybe fix the bias in open data than in, for example, corporate data.
I don't know. It depends on the data set, but I do see that if something is open and also the people who are doing the investigations on the data set need to put their findings back, I mean, that would help.
Can you give some examples of some concrete questions you can ask yourself as an organization? Like, is my data set, does it contain bias, or is it fair enough? How can you check that?
I think first of all that's very hard to do. I mean, let's be fair. That's going to be very hard to do, but you can put some effort in.
There must be some low hanging fruit though.
I mean, first of all, you should really look at the origin of your data set. Where does it come from? Really think through. You should think at each point, each decision moment in constructing the data set, training the model, looking at the results. Are there moments where bias can seep in? Right? You should really ask that question, and then.
But the answer is already yes. Right?
Yeah, but then how is it concretely possible for bias to have been crept in? And then even then there are things that you are and then you can try to intervene, but then even then it's possible that you're not seeing some things, or that there's like multi-dimensional correlation somewhere going on, that a linear combination of all of these variables ends up creating a bias set that you cannot just see. Well, then you need to test. You need to have people verify, but you also need to test, if I have a group of people and another group of people, let's say this time elderly versus young people, do we get different precision and recall for the two groups, for instance? I think that's a very important test. And then, if you use,
but it feels to me a little bit like there's a higher abstraction here. For example, already like saying like, okay. Look at, for example, at the precision and recall of my different classes, for example, and how and do they reflect what I wanted to reflect?
Yeah, right? Exactly. That's the higher. That's the rule. That's the rule. Now, but there are like hundreds of different ways that you can segment your data in different groups. So there is, and of course, precision and recall is never going to be equal for the group, exactly equal. It's impossible. So, and one reason for it is that it depends on sampling error also from the test set that the test set is also a sample. It's sampled from a greater population. So there is sampling error there. There's some randomness in which ones get selected, end up in the test set.
Yeah, plus you shouldn't also forget that in some cases you want to target certain demographics, right? If you are, for example, a company that wants to market lady products, for example, right? You target women. Yes, and actually now you open up another point of discussion, I think, because whatever lady products mean, by the way, I don't know.
I'm sure you're familiar with. Yeah. I think the one important point here is to what extent is the conclusion, even though it's biased, correct, right? Because then you might want it or not, depending a little bit on ethics.
Maybe it's not a bias, it's what you're trying to learn.
Well, in psychology, there's a huge discussion, has been going on already for ages, about the truth of stereotypes, right? Because sometimes some people argue they must come from somewhere, right? And maybe there are some differences between people that are actually true, even though they might not be fair, right? So
might not be their fault, might not be something you should but they might be there.
It's possible, and there's this is called the kernel of truth hypothesis about stereotypes, and it also
What, the kernel?
The kernel of truth,
right?
So there is a little gray kernel of truth that and then
I was thinking like a mathematical kernel. Okay.
Yeah, no. Actually, like a mice, But that's in social psychology. There's a big thing. So there's work by Lee Sim from Rutgers University that is really looking from a different way at how stereotypes are defined and to what extent they can be true. It's impossible to test whether stereotypes are true. Because, to know whether a stereotype is true, you need to take into account an entire population. It's very hard to do. And by the way, most stereotypes are defined by the fact that they are not true.
And stereotypes are also not global.
No, definitely not. And they're they can be highly localized.
Right.
In some cases, it might mean that if you need that information, is that you also need to make transparent how you're using that information. And if that's the case, you limit yourself to either the non-black box algorithm, which are usually less powerful, but at least you can explain how it comes to different decisions.
Right.
Or you need to use this newer cutting edge stuff where actually explanations are also part of the train.
But does that matter? I think in this case it doesn't matter, right? Because whether it's explainable or not, if the bias is in there, the bias is in there. So it's more about reducing, the effect you see on the actions it takes.
Yeah, it's tough. Yeah. It's very tough. It's also why I prefer to work with data that's not about people.
Obviously, but either way, you're indirectly influencing people. Right?
Yeah, I'm thinking. I can't help but thinking about the Cambridge Analytica stuff all the time now.
Right.
As soon as we start talking about people and segmenting into groups and trying to predict something and influence, and it's clear to everyone that ethical lines have been crossed there. But it's not such a black and white situation. You can easily seep into a situation where suddenly you start using information about people to influence them.
Right.
Using algorithms, and I don't know. It's also, you cannot say stay clear from it, don't do it ever, because there's clearly value.
No, and you could also learn things about. For example, recommendation engines, right? Like if you are a very big online web shop that sells everything, and then somehow your recommendation engine learns for a certain cluster of people to recommend them unhealthy products because, I don't know, things with lots of sugar or...
Because they buy it.
Because they buy it. But these people already
but they buy it.
And they buy it. Yeah. So that's again like a self-reinforcing thing. But then who is to say that, who's the company to judge that these people are not to be allowed to buy these products?
I don't know. I think you should, it's clearly an ethical problem. I think that's what I like about, Blendel, this Dutch newspaper aggregation. I started reading that when they came out. I liked it a lot because you could pay per article across all kinds of newspaper. But I also liked the fact that they would send me recommendations every day, and they were pretty spot on. But they would always also include 1 or 2 recommendations that were outside of your bubble, right? So there were things that you would otherwise have never read, and that's. It turned out that was very interesting to read, but I also was less likely to read them because I was actually less interested in it.
That's what we at Anchorman call post-filtering, right? So still like after, especially something like collaborative filtering, more advanced techniques are popping up now, but especially, I was just this weekend, I listened to Lex Friedman's podcast with, sorry, I forgot his name, but the guy behind the YouTube algorithm, which still heavily relies on collaborative filtering. But you need to also...
And works really well for my son, by the way.
Yeah. Exactly. So, there you have this runaway problem, right? Where some malicious actors put in violent kids videos in
terrible.
There, but that's terrible. Anyway, so if you do collaborative filtering, you create this bubble by itself, and then it's very good. What we at Anchorman, in our way of building recommendation engines, is that we then also tell people to use post-processing or post-filtering where you boost certain results because, for example, they are new, right? And they don't have a history yet on which you can filter.
So I think that is the responsibility of the company. I completely agree, of the business, to make sure that you at least give also people the option of choosing to do things that the algorithm would not predict, for instance. But in the end, humans keep on being human. If the algorithm is really accurate and really, really capable in giving high quality predictions about what that person is interested in, then even though you offer the alternatives, people will still not read them, which is what happened to me when reading the newspaper articles. Right. So in the end, you can, but I think that's not a excuse not to do it.
Right. But for me, it depends. Of course, also it's not. There's a spectrum there as well. Like, if you are like, how far out do you go with showing random stuff? I mean, you can also still use different. It doesn't need to be completely random. It can still be, for example, based on something that's accelerating in views.
Yeah,
so thereby implying that a lot of people somehow seem to think it's interesting, even though that you being the user of the recommendation engine might not have it in their bubble.
Yeah, I think random is really a bad alternative to a recommendation engine. I definitely think there should be like some intelligence behind this.
Yeah.
There should be some algorithm there. I agree.
And don't be fooled by randomness. Yeah. Shout out to Nassim Taleb.
Yeah.
Well, I think this wraps it up for our first episode. Went by pretty quick, actually. So I feel like there's lots more to cover. So we're already looking forward to the next episode, which will be somewhere next month. So thank you for listening. Ron, thank you for your insights. And
thank you to you.
Yes. See you soon. Did we inspire you? Tune in for the next episodes. Or visit our website, anchorman.nl. There you'll find more on bootcamps, AI masterclasses, or careers. See you at the next episode.